Good day, viewers. Welcome to my YouTube channel. I'm your presenter, Mr. Mlenga. So today I want us to look at the integration of functions with fractional or negative power. Okay, so we want to integrate functions that consist of a fraction and a negative power. So let us look at the first example. Integrate. So we have the integral of this function right here, the root of x minus 2 over x squared dx. So we have to integrate this function with respect to x. So step 1, we are going to rewrite the function the way it is. Okay, so we are going to write it like this. We'll say integral of root of x, the integral of root of x minus 2 over x squared dx. So that is our step 1. All right, so after writing like this, okay, next step now, step 2, we are going to rewrite this because it's having a root, okay, root of x. So we are going to write this root as a power of x, okay. So it's going to be like this, the integral of x raised to the power 2, because this is the square root, which is the same as 1 over 2, all right, minus 2 over x squared. Now here we can't integrate properly, so we have to rewrite this as well. Now this x squared is having a positive power, okay, so we are going to write it like this. We write 2x to the power negative 2 dx. Okay, now in case you are wondering where does this come from, so it's coming from one of the laws of indices. If you have something like this, 1 over a squared, okay, you can write this as a to the power a negative 2. So this is what I've just done there, okay. So I hope we are moving together. Okay, so now from here, what are we going to do? We are now going to integrate this function. We are going to integrate this function. So the way we are going to integrate it, you say x raised to the power of half plus 1 minus 2x raised to the power of negative 2 plus 1. Okay, so here you have to divide with what you have done to the power there, 1 over 2 plus 1. So even here we divide with this negative 2 plus 1, then plus c. So the reason why we are adding a c right here, because this is an indefinite what? Integral. Okay, so it must have the arbitrary constant right here. So what you are doing is, this is integration, okay. So when you are integrating functions on the power right here, you are supposed to add a 1. So that's what I've done. 1 over 2 as the power plus 1. Even here negative 2 as the power, I've just added a 1. So whatever you do here on the power, when you add a 1, have 1 over 2 plus 1, you also put it as your denominator right here. Even here negative 2 plus 1, you put it as your denominator. Now from there, we're going to do this. Let us simplify. So x to the power 3 over 2, because when you add 1 over 2 plus 1, you get 3 over 2. Again over 3 over 2, because it's the same, minus, okay. Now here we have a negative and a negative right here. Okay, before you do this, let's just work it out. So we say 2x negative 2 plus 1 to give us a negative 1 over negative 2 plus 1 to give us a negative 1, then plus c. So I hope that you are following. Okay, so from here, what will be our next step? So I want you to follow me nicely. What will be our next step from here? So in case you are wondering where the 3 over 2 came from, I just added this part, okay, where I said 1 over 2 plus 1. The way we can add this, we are going to multiply by 2, which is the denominator there. So this and this will cancel, remain with 1 plus, okay. So here it's a 1. 1 into 2 is 2. 2 times 1, get a 2 over a 2 right here. So when we add 1 plus 2, it's a 3 over 2. This is where it came from, right there. Okay, so let's see how best we can answer now from this stage. Okay, so we continue. From this stage now, what we are going to do is we write x raised to the power 3 over 2 over 3 over 2. So this negative and this negative, the sign here will change. It will be a positive, okay? So meaning 1 into 2x to the power negative 1, you get 2x to the power negative 1 plus a c. Okay, so from here, what will be our next step? So it's very simple. I hope that you are following. So from there, this is what we are going to do. Now, our main interest is right here. Okay, right here. So we can't leave our answer in this stage with a fraction as a denominator. Okay, we have to rewrite it in the simplest way. Okay, even this one, it's having a power of a negative 1. So don't leave it at this stage. You have to rewrite it. So for this one, the way you are going to rewrite it, you are going to say 2, okay? Then you say the root of x to the power 3. I hope you are following, over the 3. Then plus, so for this one, 2x raised to the power of negative 1, you are going to rewrite it like this, 2 over x. Then plus c. So this will be marked as our answer. Now let me just explain something here. Here what you have done is right here. Remember you had x raised to the power 3 over 2 over 3 over 2. So what I've done is I've just used the reciprocal of this 3 over 2, which is 2 over 3, okay? So that's what I did. I multiplied right here. I said times 2 over 3 is the reciprocal of this. So these two are multiplied with the x there, it will be 2x, okay? Now, for this one, 3 over 2. Remember, if you multiply 1 over 2 times 3, that's when you're going to get 3 over 2. So this 1 over 2 is representing a root, okay? A square root, which is right here, a root. So this 3 will remain as the power on what? On x. So this is where the root came from, root, then x to the power 3, just for this one. And then over this 3 right here. Okay, this is what gave us this one. Now for this one, remember one of the laws of indices, if you have a raised to the power of a negative 1, you're not supposed to leave it like this, okay? You have to get rid of the negative there on the power. So we're going to write this as 1 over a. So same with this principle, which is right here. These two will remain on top over this x is the one that is having a negative 1. So it will be 2 over x, meaning this x will have a positive 1 as a power, okay? So even if you don't show it, it's fine. So I hope you have gotten something from here, from our example 1.